Add 1 2 3 1 2 3. We're back, bitches, and today we are checking out recursive replication, a Python exercise. What the hell was that? In Codewars, from Codewars. You need to design a recursive function called replicate, which will receive arguments, times, and number. The function should return an array, really a list, containing repetitions of the number argument. For instance, replicate 3 5 should return a list of 3 5s, as you see. If the times argument is negative, return an empty list. As tempting as it may seem, do not use loops to solve this problem. Yeah, this is a recursion problem. So you see the title up there, recursive replication. We have to use recursion to solve this one. I think this is the first recursion exercise I've done in my whole series, so this should be good. Yeah, so replicate 3 5. You get the number of times to replicate and then what you are replicating. So through recursion, we're going to build a list where we have the same value over and over again in a list, using recursion. All right, so there it is. Let's dive into it. Where you're gonna add the same value to a list over and over again using a recursion. So I don't think I need to say it a fourth or a fifth time. Let's just get into it. I'm gonna use PyCharm for the composition. Just wanted to see if there's like another test case here. Yeah, I'm gonna grab a couple of these test cases just because I'm gonna be testing them in another environment. I might want to use them. I'm not sure yet which one I'm going to use, which ones I'm going to use. I'm muttering to myself on a damn YouTube video. How you like that? All right. Bring it over to PyCharm here. Yeah. The size is probably good enough. Okay. So, of course, in replication, you've got to create a base case. Like, in replication, you do the recursive case and the base case. The base case is the ending condition, like how does this recursion loop stop? The recursive case is the looping condition, where like if this is present, we're going to keep doing the recursion. We're going to keep looping, whatever you want to call it. So I'm going to create the base case right now, and we're being asked to do something a certain number of times. So we're going to count down the times. We're going to reduce the times every time. So I'm going to say if the times is less than or equal to 0, then I'm going to return something. And what I'm going to return is an empty list. Because you'll see with the recursive case, I'm building a what I'm doing here is I'm going to be really concatenating lists over and over again. I'm going to return a list at the end, an empty list at the end, to kind of tack that on to the end to finish the concatenation, basically. Because whatever I return is going to be concatenated. Of course, you don't see it yet, so I'm going to show you now. So I'm kind of explaining it backwards because you kind of need to see the recursive case to be able to understand why I'm returning an empty list here. So here is the recursive case, and what I'm going to do is number is what we're going to be replicating in the list, as you see in the test cases. So I'm going to do number plus, because I'm going to have for every turn of this recursion, I'm going to concatenate a single element list to the rest of what I have, really just duplicating the value in a list over and over again. Because if you concatenate a one element list to another one element list, you have a 2-element list with the same value. So that's what I'm doing. So I'm going to do one element list plus, and then I'm going to do the actual recursion, which for those of you who don't know, recursion is a function calling itself. And for this recursive call, I'm going to do times minus 1 because you want the number of times to reduce every time you recurse, because if you don't, you're going to have an endless recursion, or it's going to get stopped by the Python interpreter. And my second argument, of course, is going to be the number that I'm duplicating, and that isn't going to change. And there we go. So that really is the solution. I got my recursive case, and I've got my base case. So I'm going to run the test case that I already have set up, which is 3 and 5. I'm going to go ahead and run that, and here we go. All right, we got 3 5s, as you would guess. So times the first argument, number the second argument. Let's just change it a little bit just to show you. 10 5s. You see down here we got 10 5s. Good to go. I'm going to try another one of these test cases. I'll do 8 and the 0. 8 0. There we go. You got 8 zeros. That looks like 8 zeros to me. That looks pretty darn good. Yeah. And let's, for the heck of it, let's experiment. And let's go to line 9 and take out the times minus 1, leaving times to be the same every single time. So now every time I run this, the times are going to be 8, and it's just not going to stop. So just want to show you what happens here. Yeah, maximum recursion depth exceeded, because the Python interpreter has a recursion limit built into it of, I believe, 999. So it's just recurses over and over again. Yeah, because the times doesn't change, and it never gets to the base case because the times doesn't change. So you can liken recursion to regular iteration, where yeah, something has to break the condition, because if not, it's going to keep going. All right. Enough of this. I'm going to repair this. One more test, and good to go. So I'm going to pop this in to my Codewars interface and ensure that it passes, so I can jet. So I can Joan jet up out of here. All right. We're going to test. Looks good. Going to attempt. Looks good. All right. There we go. There we go. There we go. Impressive, impressive, impressive. All right. That's it. So what we have here is a recursive replication. Hope you learned a little bit about recursion. I know I didn't really give you a tutorial, but maybe you saw something in the commission of here that helped you understand recursion. If you did, if you did. If you didn't, you didn't. But either way, I'm out of here. I'm good. So I'll see y'all later. Talk to y'all later. I am out.